Hello everyone. In today's video I will discuss about Newton's law of motion. The first law of motion. A particle is stationary or moving with constant velocity does not change its state of motion until any external force is applied on it. That is, if the vector sum of all forces acting on a particle is 0, then the acceleration of particle will be 0. In the figure 3.1, a particle is initially at rest and the vector sum of all forces acting on the particle is 0. So the particle will remain at rest. In the figure 3.2, the particle is moving with constant velocity and the vector sum of all forces acting on the particle is 0. So the particle will continue moving with constant velocity. Let's talk about inertia. According to first law of motion, an object does not change its state of rest or motion with constant velocity if the net external force acting on the object is 0. If some net external force is acting on any object, its velocity changes. We observe that on application of equal net force, a heavier mass velocity changes by a smaller amount and a lighter mass object changes its velocity by a larger amount. The property by virtue of which an object shows unwillingness to change its state of rest or motion with constant velocity is called inertia. A heavier mass shows larger inertia and a lighter mass shows smaller inertia. Newton's second law of motion. The net force acting on a particle is product of its mass and acceleration. Mathematically, we can write that the vector force equals mass times vector acceleration. In the figure 3.3, a mass block is tied on a fixed support by a light rope. The acceleration of mass is 0, so we can say that the net force acting on the mass is 0. In the figure 3.4, the rope is cut and mass started falling with acceleration due to gravity g. So we can obtain its force, net force F equals m vector g. Newton's third law of motion. If a body applies force on other body also applies equal and opposite force on first body such that the line of action of the two force remains same. In the figure shown, a mass block is kept on a frictionless table. The forces acting on the mass block are normal force in vertically upward direction and gravitational force mg in vertically downward direction. The normal force is exerted by table on the mass block. So according to the Newton's third law of motion, mass block will also exert equal amount of force on the table in vertically downward direction. And since Earth is attracting the mass block with the gravitational force mg, the mass block will also attract the Earth with the same force towards itself. Now let's discuss about pseudo force. Newton's law of motion is valid only in inertial frame of reference. When we need to analyze force and acceleration of a body from accelerated frame of reference, an additional force called inertial force or pseudo force is considered to be acting on the body. The pseudo force acts in direction opposite to direction of acceleration of non-inertial frame of reference. The magnitude of pseudo force is mass times the acceleration of non-inertial reference frame. Now let's discuss about working with Newton's law of motion. While working with Newton's law of motion, in the first step we decide the system. The system on which laws of motion are to be applied can be a particle, a block, or a combination of blocks. Next step is to identify which all forces are acting on the system identified. So the forces can be tension force or normal force or gravitational force or any other force, any other contact force or electrostatic force. The next step is to identify the constraints. Constraints are the conditions imposed because of certain characteristics of the system. Constraints are used to write the equation relating the variable involved in the problem. For example, The constraint can be constancy of length of string or inclination of wedge. Next step is to draw free body diagram. Make a separate diagram of each block or particle with the forces and accelerations shown graphically. Using third law of motion, we can decide the direction of forces acting on the blocks. Next step, we can choose the axis and we can write the equation of motion by using the Newton's third law of motion, which is force equals mass times acceleration. So in the x direction, the force Fix will be equal to max, and in y direction, summation of force Fiy will be equal to may, and in z direction, summation of force Fiz will be equal to maz. Now let's discuss a problem based on Newton's law of motion. An elevator cab that weighs 27.8 kilonewton moves upward. What is the tension in the cable if the cab's speed is A increasing at the rate of 0.970 meter per second square and B decreasing at a rate of 0.970 meter per second square? Solution: the weight of the cab is W equals 27.8 kilonewton. Let's draw the free body diagram of elevator cab. The forces acting on elevator cab are the gravitational force W in downward direction, tension force T in vertically upward direction. With these forces, let's assume that positive direction of y-axis is in upward direction, and we can write the equation of motion. Since the acceleration is given, a equals 0.970 meter per second square. The equation of motion will be T minus W equals W by G multiplied by A, or T will be equal to W times 1 plus A by G. On putting the values of W, A and G, we will get the value of tension as 30.55 kilonewton. In the second part of problem, the acceleration is given as minus 0.970 meter per second square. So the equation of motion will be T minus W equals minus W by G multiplied by A. On simplification, we'll get T equals W times 1 minus A divided by G. If we put the values of W, A and G, we will get 27.8 multiplied by 1 minus 0.970 minus 9.8 kilonewton, which will be equal to 25.04 kilonewton. So we observe that while acceleration in the upward direction, the tension in the rope is increased, and while the deceleration in upward direction, the tension in the rope is lesser. Now let's discuss one more problem on Newton's law of motion. The elevator shown in figure 1 is descending with an acceleration 2 meter per second square. The mass of the block A is 0.5 kg. What force is exerted by block A on the block B? Let's consider mass block A as the system. The forces acting on the mass block are gravitational force vertically downward of magnitude 0.5 g, normal force by mass block B surface N. Free body diagram of block A will be the normal force showing upward and the gravitational force in the downward direction, and the acceleration which is in downward direction, and we take the positive direction of y-axis in downward direction, and we write the equation of motion, summation of all forces equals mass times acceleration. So the forces in the downward direction is 0.5 multiplied by 9.8 minus n equals 0.5 multiplied by 2, or the n will be equal to 0.5 multiplied by 9.8 minus 0.5 multiplied by 2 equals 3.9 Newton. Now let's consider the block B as the system and draw the free body diagram. The forces acting on the block B are the gravitational force in downward direction, the force N1 which is acted by the elevator floor surface on the block B, and force N which is acted by the contact force of the surface of block A to the surface of block B. So we need to obtain the force N which is acted by the block A to the block B. So it will be equal to 3.9 Newton, and since it is acting on block A from block B, so the forces will be in opposite direction to the force acting from block B to block A, and the magnitude will be 3.9 Newton. Figure 5.17 shows three blocks attached by cords that loop over frictionless pulleys. Block B lies on a frictionless table. The masses are MA equals 6.00 kg, MB equals 8.00 kg, and MC equals 14.0 kg. When the blocks are released, what is the tension in the cord at right? In this question, we need to obtain the tension in the cord connecting the blocks B and block C. So let's draw the free body diagram of block C. The forces acting on the block C are tension in upward direction and gravitational force mcg in downward direction. And the acceleration, let's assume in downward direction with magnitude A. So we can write the equation of motion as T1 minus mcg equals minus mca. Let's call it as equation 1. Next, let's draw the free body diagram of block B. The forces acting are T2 in leftward direction and T1 in rightward direction, and normal force in vertically upward and gravitational force in vertically downward direction. The acceleration will be in the right direction and the magnitude will be same as A. So we can write the equation of motion as T1 minus T2 equals MBA. Let's call this as equation 2. And let's draw the free body diagram of block A. The forces will be MAG, the gravitational force in downward direction, and T2, the tension force in upward direction. The acceleration will be in upward direction with the same magnitude A. The equation of motion will be T2 minus MAG equals MAA. Let's call this as equation 3. If we subtract the equation 3 from equation 1, we will get T1 minus T2 plus MAG minus MCG equals minus MCA minus MAA. And the value of T1 minus T2 can be obtained from the equation 2. T1 minus T2 equals MBA. If we put the value of T1 minus T2 in this equation, we will get the equation MBA plus MAG minus MCG equals minus MCA minus MAA. On solving this equation, we will get the acceleration value as MC minus MAG divided by MA plus MB plus MC. The equation 1 gives the value of tension T1 as MCG minus MCA. On putting the value of A in this equation, we will get the value of tension T1 as mcg minus mc multiplied by mc minus mag divided by ma plus mb plus mc. Or we can get the tension T1 as mcg multiplied by 2ma plus mb divided by ma plus mb plus mc. On putting the values of ma, mb and mc and the acceleration due to gravity g, we will get the tension T1 as 14 multiplied by 9.8 multiplied by 2 multiplied by 6 plus 8 divided by 6 plus 8 plus 14 Newton. On solving this expression, we get the tension T1 as 98 Newton.